All right, well, let's get started. Everybody can hear me and see me. I'm going to switch over to my document camera here. So, can you see that? Okay.
Yes.
Okay. All right, this latest assignment talks about longitude and time. And remember, we tell time by the position of the sun. And if you have any questions, just stop me or put it on the chat or something, and I will try to answer it. But just quick review before we start and do a couple of problems is here's the Earth, and we draw it with the Earth with the North Pole sticking out of the paper. So that we're looking at it, the North Pole is sticking up like this. And then I always like to put the sun over here on the right side to make it consistent. So this is the Earth. And so what we're really seeing is this circle around here is actually the equator. If you can imagine, this is the North Pole, then the fattest part here would be the equator. And when Herb is over here, then the time is noon. Okay. When it's noon over here, it's noon because here's Herb, and the sun is directly over his head or on the meridian, so that would be noon. Now, when Herb is up here, remember the Earth spins counterclockwise, so it's spinning this direction. He's gone 90 degrees away from noon, but 90 degrees is 1/4 of the way around. Well, when we have 24 hours, 1/4 of that is 6 hours later, so this is actually 6 p.m. Okay, so from here to here, to rotate that far, the Earth takes 6 hours. Okay, same thing when you're over here, we've rotated 6 more, or we're exactly opposite. This is midnight. And then when you're down here, this is 6 a.m. Okay. And then what we have to look at is, so whatever is directly over Herb's head is on his meridian. But we can draw a line at his feet for each position, and we can figure out which way east and west is. So in this case, east for the Herb at noon, his east is straight up and his west is down. For Herb at 6 p.m., east is this way. Remember that if you don't know which way east is always the direction the Earth is rotating. We rotate to the east. So if the Earth is spinning this way, then east is going to be that way and west will be this way, which makes sense because at 6 p.m., if you look towards the west, the sun's going to be low in the west or setting about that time of day. Over here, we have east and west. And down here, we have east and west. Notice at 6 a.m., east now points towards the sun because the sun is rising and it's in the eastern sky. All right. So the biggest thing about doing longitude problems is you have to remember that we take the whole Earth and it's split into time zones. And there are actually 24 time zones around the Earth. Each of them has 15 degrees of longitude per hour. So just memorize that number. All right, now if I do a problem, so let me create a problem like one that is on your homework. Let's say it is 11 a.m. for Herb and 1 p.m. in Miami, longitude 78 degrees west. What is Herb's longitude? All right, so to figure this out, to do these kind of problems, we always draw the Earth, just like I was drawing before, and I'm going to put the sun over here. Which means that the point directly from above, below the sun is noon. But if I look at the problem, it says it's 11 a.m. for Herb. So Herb is actually going to be here, right here, at 11 a.m. Remember, straight down is 6 a.m. And then it'd be 7, 8, 9, 10, 11, noon, 1, all the way up in here. Remember, this was 6 p.m. and this is midnight. Okay, so now I got Herb on the diagram at his right spot. And then it's 1 p.m. in Miami. So I'm going to say, oh, noon, I'm going to go up 15 degrees. That's where 1 p.m. is. This is Miami. So far, so good? Okay, then I have to know how many degrees there is from there to there, and that's where I have to have that memorized. I say, how many hours is it from 11 a.m. to 1 p.m.? And that's a 2-hour difference. And then I just multiply it by the 15 degrees per hour, and I get that the difference is 30 degrees. So it's always going to be 15 degrees per hour. This is the difference in time. And then I know that this angle is 30 degrees, but I didn't ask that. It's asked what is Herb's longitude. Remember, longitude is always measured from the prime meridian, from England, essentially. So I have to figure out where England is. Well, I do that by using the known longitude. So Miami is here. I'm going to go over here, 78 degrees. And this is 0 degrees, or the prime meridian is right here. Okay. And then, if the prime meridian is here, we need to know how far it is from the prime meridian all the way to Herb. Well, if we just look at this, oh, well, it's just going to be 78 degrees plus 30 degrees would give us that whole angle. Or the answer is 108 degrees west. Questions about that? Should we do another one? I assume your lack of answers means yes, you want me to do another one.
Yeah, except sir, yeah, if the longitude is like how far away from like meridian, like east and west, so can we do one with the like east? I mean, like if something is like let's say instead of Miami, if the longitude was 78-degree east, can we do that, or it's
Yeah.
always gonna be west?
Well, I usually do west just because we're in the United States, and the United States is all west. But yes, you can do east. You see where prime meridian here? If I was going to draw this line here, remember, from the prime meridian, this direction is east, this direction is west. So that's why I went 78 degrees west to get to Miami.
Yeah,
You could do exactly the same thing if it was east, you're just going to go this way.
Okay.
Okay. So it's kind of like the mirror image of it. You just flip it the other way. But I will tell you, on the homework and on the test, they'll probably all be in the west.
Oh, okay.
Just because, you know, we're in the United States and we're in the west.
All right.
But I can do this the other way. Watch what happens if I do it this way. So I'm going to change this here. Let's do this. It is 11 a.m. for Herb, but 8 a.m. in Hawaii, which is at a longitude of 150 degrees west. What is Herb's longitude? All right, so we're going to do exactly the same thing. We just got to be careful here about making sure that our drawing is accurate. So here's our Earth, sun's over here. Okay. Remember, noon is here. 6 p.m.'s here. 6 a.m.'s here. And midnight's here. Okay. So 11 a.m. Herb's going to be in the exact same spot because I made it both times 11 a.m. So Herb's right here at 11 a.m. Okay. But now Hawaii is at 8 a.m. Well, 6 a.m. is down here, so 8 a.m. is going to be about here. So this is 8 a.m. and this is where Hawaii is. Okay. Now I have to do exactly what I did before. How many hours difference is it from 8 a.m. to 11 a.m.? Well, it's 3 hours difference. And remember, I just always multiply that by 15 degrees per hour. So 3 times 15 is 45 degrees. I know that the angle between those two is 45 degrees. But here's the part that's different. As you see, the longitude 150 degrees west is from Hawaii. It's not from Herb, it's from Hawaii. So I have to go from Hawaii down here, and I have to go 150 degrees west. So I have to go this way. Here's the 0 degrees. Here's the prime meridian. And that angle, that whole angle there is 150 degrees from there all the way to there. And now I need this angle right here because I need to know how far Herb is from 0, from the prime meridian. So in this case, I'm going to have to take 150 degrees and I'm going to subtract 45 degrees. And I'm going to get 105 degrees west. You see, this time I had to subtract. But on the previous one, we added. What's the difference? The difference is, in this case, in the first one where we added, Herb's time was earlier than our reference point. In this one, Herb's time was later than the reference point. Now, if you draw your picture right, then it becomes very clear whether you add or subtract. Questions? Everybody comfortable with this? Okay, well, there's only one other type of question, and that is how early stars rise. And what you have to remember is the difference between a solar day and a sidereal day. Remember, solar is by the sun, sidereal is by the stars, is 4 minutes per day. Meaning the solar day is 4 minutes longer than a sidereal day is. So if I say a star rises at 1:05 a.m., when will it rise No, let's do 8 days later. All right, this is, again, is very easy. What we do is we say we know it's 4 minutes per day. We know how many days, so we're just going to say, oh, well, 8 days times 4 minutes per day. And when the days cancel, you're left with 32 minutes. So that means the star in 8 days is going to rise 32 minutes earlier. But the tricky part then is you got to figure out when 32 minutes is. So I'm going to start at 1:05 a.m. and I have to subtract 32 minutes. Well, 5 minus 2 is 3. That's easy. But then I can't subtract here, so I have to borrow from here. This becomes, instead of going to 0, this becomes 12. And this becomes 6, because 1 hour becomes 60 minutes. Because we have a weird base 60 time thing. So 6 minus 3 is 3, and it actually is at 12:33 a.m. when it rises. So that is the answer. So the easy part is just multiplying by 4 to get the how much earlier. The tricky part is subtracting and getting the time right. All right, if you can do those 3, you can do the homework and you'll do well on the test. Is there anything else you want me to do or you want to see?
I'm sorry, when is the test again?
It's going to be a week from Thursday. I think it's the 24th. So next week. There will be a another quiz on Friday about moon phases, and there'll be one more homework due next, like Monday or Tuesday, and then the test will be on Thursday. Okay, well, if there's no more questions, I think we'll call this good. And I will post this video up so you can refer to it. I'll put it in D2L. So if you want to check it again and see how I did the problems, do them exactly the way I do it, it'll work out perfect. And again, email me if you have any questions.
Okay, thank you.
Okay, thank you. I'll see you later.